All right, so let's start Unit 4. It's a fun unit, so this is all about rational expressions. And let's first start, the first lesson is about simplifying. But first let's start with what is a rational expression. So the answer is the ratio of two polynomials. That's the Google definition. So it could be just like something like 1/2. That's a rational expression. Or it could be like x plus 2 times x minus 3 over x plus 1. Something along those lines. So, AKA it is a fraction. Also, something to know is an expression is something that does not have an equal sign, so it's a fraction with no equal sign. Therefore, since there is no equal sign, we cannot solve for x, so all we can do with these are simplify them. So first, let's start with simplifying by canceling like terms in the numerator and the denominator. So if it's not in the numerator and denominator, you can't cancel it, and then leave your answer in simplest form. So letter A, let's start off with an easy one. Just a good old fraction. We are reducing. It looks like you can divide the top and the bottom both by 4. So this would be 1/6. Okay, this next one looks like you can divide them both by 2. So that would be 11/4. You can't reduce again. Okay, so now here's where we get to the fun stuff. So for this one, I'm going to write it out in expanded form. I will not do this every time just for this one, but just to kind of show you how to do this if you get stuck on one, that you can always go back to this. So expanded form, what would x squared y be in expanded form? Well, it would be x times y. Okay, and then the denominator, xy to the 6th would be 1x and then 6y's. Okay, so now here's the fun part. You get to cancel. And remember, you can only cancel something if it's in both the top and the bottom, so the numerator and the denominator. So in this case, we can cancel 1x. We can only cancel 1 because that's the most that's in the bottom. Looks like there is one more extra on the top, which is fine, but we just can't cancel anymore. And then we can also cancel 1y. So what does that leave you with for your answer? Put it all back together. So what are you left with on top? Just an x. And what are you left on bottom? Well, you're left with 5 y's being multiplied together. So that would be y to the 5th power. Okay, so here's how I would do that exact same problem without writing it out in expanded form. On the next one, this is how I'll do it. Okay, so there's x squared over x. Go back to the original problem. X squared over x. How many can you cancel out of both the top and the bottom? Just 1. So all of those cancel out, and this cancels out to be x to the 1st power. And then how many y's can you cancel out? Well, it looks like there's 1 on top, 6 on bottom, so you can cancel out 1, and then this will be left with 5. So whenever you put all of that back together, you end up getting your answer, x to the 1st power. You can write it like that or just leave it as x. And then on the bottom, you have y to the 5th. Okay, one last thing before we move on to the next one, something to check for that you're finished. Is there only one term with an x in it? Yes. Is there only one term with a y in it? Also yes. So since that's the case and there's no numbers in this problem like out front that we can reduce, you are finished. So if you would have had multiple terms, like say you still had some x's on the bottom, you would have to keep going, just like whenever you reduce fractions. All right, let's do another one. And what's cool about these problems are my favorite. You don't have to do it in a certain order. So do what your brain sees first. Okay, so let's just go for it. So I'm going to start with my A's. You could start with your B's or your C's, but I'm just going to do A's because that's what my brain sees first. So I have a to the 6th over a to the 3rd. So how many can I cancel out of both top and bottom? That's 3. right? So all three of them cancel here, and this turns into a to the third power. Okay, on the next one, you have b to the fourth over b to the seventh. How many cancel? 4. And so this would be b to the third on the bottom, because you can't just flip it up to the top. And then c to the 13th over c to the 13th. Sweet. All of those cancel, so I don't have any more c's left in the problem. So let's clean this up and write it as an answer. So I would have a to the third is all that's left on top over b to the third. Cool. Okay, another one. Now, if you notice, I threw some numbers out front, some coefficients at you. So you're going to treat those just like a fraction. So 2/8, that simplifies to be 1/4. And then x to the 5th over x to the 4th, that means 4 of them can cancel. So all of those cancel out, and this becomes x to the first power, right? Because 4 cancel, you're left with 1. And then you have y over y to the 4th. That means 1y can cancel, and this becomes y to the 3rd. All right, clean it up. There are a couple different ways actually that you can write this, but here's one of them that's perfectly acceptable. So you could do 1x to the first power over 4y to the 3rd. Or how you'll probably see me write it on that numerator, I would just write it as x over 4y to the 3rd. Either one of those I am perfectly okay with. All right, next one. So we got a little bit more going on. So what do you see first? I see these 2 x's. Let's cancel those. Cool, that makes it a lot easier. And then I have 4y over 10y squared. So I'm going to do the 4 and the 10. That becomes 2/5. And y over y squared, that means one of those y's will cancel. So this will end up being y to the first power. So then put it back together. All that's left on top is a 2. All that's left on the bottom is 5y. Double check, can you reduce 2/5? Because sometimes you do have to reduce twice or 3 times even. Can you reduce 2/5? The answer is no, so I'm leaving it. Okay, now I'm going to throw a binomial at you. So a binomial is something with 2 terms. It's usually separated by parentheses if there's more than one. And it's it's a binomial because there is a plus or a minus sign in there. Okay, so just like whenever you were reducing fractions, you're going to do the exact same thing, except you have to do a binomial, like a binomial reduces with another binomial that is exactly the same. So like for this one, x plus 2 reduces with x plus 2 because they are the exact same. Okay, so nothing like it can't be x plus 2 and x minus 2. You can't reduce those. You also can't reduce like a partial binomial, like, oh, this x and this x, or this x and this x. No, it has to be the whole set of parentheses. So since those reduce, what are you left with on top? You have x plus 1. And then what are you left with on the bottom? Well, if everything cancels, then that is just 1. Another way you can write this, okay, let's talk about the numerator. Are those parentheses doing anything for you around the x plus 1? The answer is no, because there's not another binomial and there's no numbers out front that would be distributed in. So you could drop those parentheses and write x plus 1. Also, is that denominator of 1 doing anything for you? The answer is also no. It doesn't hurt or help. I mean, it doesn't matter. You can write it either of these 2 ways. I'm perfectly fine with. Okay, what do you see on this one that cancels? I see the x plus 3. So what are you left with on top? 1 over, and you have to have the 1 on top for this one. It does matter. And then you have x minus 5. Parentheses are optional in your denominator. All right, getting a little bit more fun here. What do you see? First thing I see are these x minus 7s. They cancel. X minus 1s cancel. So you're left with x plus 2, parentheses optional because there's only one, over x plus 3, also parentheses optional. Okay, this is a good one. So, what do you see first? Let's talk about, before we get into canceling, let's talk about these 3. Okay, they are all the same, which is perfect, or just fine, this doesn't matter. But if you notice, how many of them can you cancel? Well, if you cancel something on the top, you have to cancel it on the bottom. And since there's only one of them on the bottom, you can only cancel 1. Okay, so I'm going to do this one and this one. It doesn't matter if you did the first one or the last one on top. Doesn't matter. Okay, does anything else cancel? So here we have x minus 9s cancel. And so I don't think anything else cancels, so you're left with x plus 9 over x plus 6. Okay, letter K, what happens here? Well, x plus 2 cancels with x plus 2, cool. What does that give you? Well, if everything cancels, think of it like a fraction. If you had 3 over 3, what would that give you? 1. So this would turn into 1 when you simplify it. Okay, on this one, letter L, last one, we have y plus 1 over x plus 1, x minus 1. So what are you left with? What cancels, I mean? Well, the answer is nothing cancels because that's a y and these two are x's. And remember I said they have to be identical inside those parentheses in order for them to cancel. So since nothing cancels, this right here is your answer. Okay, that is it for part 1. Hope you enjoyed watching and have a great rest of your day.